Hi, thank you. Thank you for joining me today. I'm Hugo Leniak, and I'm part of the Groom team at Epic Games, focusing on both hairstyle design and the tools that enable high fidelity and hair creation for MetaHumans. Grooming is tough. It combines artistic direction with technical precision, and it's a very demanding aspect of digital human creation. Today, I will share how the MetaHuman Groom tools were developed to address these challenges as we aim to help creators deliver production quality results with efficiency and creative flexibility. So first of all, let's just take a step back and look at the technical foundations of grooming. At the core of every groom is a guide-driven system. These guides define the flow, the shape, the volume of the hair, forming the basis for interpolated strands that make up the final groom to be rendered. From there, we use a procedural node system to apply modifiers and attributes, operations like clumping, noise, curls, which are essential for adding natural variation and realism. This approach is at the heart of strand-based grooming, for example, for complex and believable hairstyles. Understanding the method is one thing, but putting it into practice is where the real challenge begins. So achieving high quality results takes time, and as style become more complex, so does the workload. Performance becomes a key factor too, so hair needs to be believable, but it also has to run efficiently, especially in Unreal Engine's context. Optimizing for Unreal Engine means carefully managing visual fidelity without compromising runtime performance. It goes without saying, but balancing fidelity and creative control begins with structure, not just the tools. So creating a hero-level groom is not about a single pass, it's about layering. So the flow of the hair sets the foundation. Clumping sets the definition of the hair. Breakups create subtle variations. And flyaways introduce movement and looseness to the hair. When all these elements are combined together and work together, the groom feels lived in and not just styled. And let's take a closer look at clumping, for example. As we see, guides give us the overall flow, as you can see on the left, right? But the interpolated hairs on their own can feel a bit uniform and artificial. To answer that in an efficient way, with an advanced clumping hierarchy setup made of primary clumps for the mass, so the big clump, right? Secondary clumps, smaller clumps for breakups, and tertiary clumps for fine detail, flyaway things, etc. Clumping breaks that uniformity, adding the structure and the natural breakups we see in real hair. It's clear that grooming digital hair is part of the few areas in character creation that demand a deep blend of artistic and technical skills. It takes creative intuition to sculpt the flow, the volume, and the detail that feel natural. It requires technical expertise to manage complexity through procedural systems. On the MetaHuman team, we set out to lower the barrier to entry and make advanced grooming more accessible to artists. The result is the MetaHuman Groom tools, a purpose-built grooming environment developed as part of MetaHuman for Houdini. It's aligned with Unreal Engine's Groom asset technical requirements, meaning strands and guides, and it's designed to streamline complex workflows without sacrificing control and quality. With MetaHuman styling tools, artists can create complex structures like braids, buns, and cornrows, all with less manual labor and faster iteration. Here, we are looking at two short hairstyles fully compatible with MetaHuman integration. These two Mohawk styles here share a similar structure, but the variation in shape and texture shows how much control artists have over form and overall character. Here we see two complex hairstyles made with buns and braids, showing how the toolset supports layered detail and precise styling. As you can see, there's baby hair and a lot of tiny subtle details. Now that we've seen a few examples of MetaHuman hairstyles, let's walk through the toolset, how it's organized and what it includes. I've made a selection of our tools to illustrate how we provide with clean graph layouts, intuitive procedural workflows, and powerful styling capabilities. That selection of tools aims at showing how we've added a set of focused features dedicated to help grooming for MetaHumans in Houdini, including a MetaHuman Groom Importer, additional styling tools to expand side effects package, and an Alembic exporter for seamless integration with the Groom asset in Unreal Engine. We want to provide a clean environment for grooming thanks to quality of life tools. The first element we provide in that regard is a node initializing the MetaHuman head topology set to a neutral shape. The MetaHuman groom head node comes with different outputs that let artists choose between different regions of the head to groom on in an optimized way, like the scalp area, the face area, the entire head. It also comes with two different VDB outputs, one with and one without the ears for better collision controls. And each output also has subdivision level controls, and it also provides preset textures for the skin and for the eyes. In Unreal Engine, a groom asset requires mandatory elements from an exported groom to be able to build correctly, such as strands for rendering, skin root information for binding, and guides for applying physics. We have built a new geometry node called the MetaHuman Groom Workspace that creates a safe environment for grooming with dedicated streams of data. As you can see here, you got one stream per essential element for the groom asset to work. Groom Workspace comes with several source modes, such as initializing a new MetaHuman head inside, or referencing another Groom Workspace in a plug-and-play fashion. In this example here, this ponytail workspace pulls the sculpted guides from another workspace called the ponytail guides, so where the guides were sculpted. It ingests that guide data. Groom Workspace also enables quick switch between different presets of colors, material parameters. There's an attribute tab that gives clean, controllable output data management. There's a stats tab that provides point and curve count for debugging purpose. And additionally, a finalized groom can be saved on disk on the fly to reduce useless cooking time. So whenever you open your scene again, you don't have to recook the groom on and on. All right, so let's start our advanced tooling tour with the element styling tools. The first set of grooming tools we provide is dedicated to creating complex hairstyles, such as braids, buns, cornrows, within minutes. The bun styling tool ingests scattered points on the skin and converts them into unique variations of donuts or knots. It can be scattered points using a scatter node, or it can be points coming from a curve you draw on the surface. In this example here, we are feeding the bun tool with a few sculpted and mirrored curves, and every point on the sculpted curve is converted into a bun that can then be transformed directly on the skin, and it's easy to adjust the height, the base radius, and the overall shape of all buns at once. The shape type can be switched between knots and donuts, along with scattering modes for high or low density generation. Many controls offer extensive flexibility in shaping the final look very easily. The tool also supports adding several variants of buns to the scattered points, assigning variants randomly or manually. So for example, here, a second variant can be changed to a completely different bun type with its own scattering, its own radius, shape parameters, regardless of the first variant. It's very easy and intuitive to use. Braids are another complex element system to build while grooming. This braid tool converts any curve input into a realistic braid with lots of easy controls and detangling. In this example here, the braid tool is connected to a guide groom node and allowing these mirrored sculpted curves to automatically turn into a detailed braid structure made of tubes. Controls for profile size, width, height, thickness along the curves are easily accessible and intuitive to use. The braid subdivision quality and the frequency of the knots can be adjusted on the fly, and there's a lot of directability on the making of the braids with additional settings like twisting and rolling, and all these parameters can be randomized to create a more organic look. So, plugged into a tube fill node, it instantly converts to curves to be used as strands or guides, up to you. And in this case, the tubes are turned into a high-density strand system meant to be rendered. Features like detangling remain active, and modifiers such as twisting per clump can be applied. Just like with the bun tool, new clump variants can be added too. So here, for example, the blue clump is swapped out for a different variant with independent control over its density, its thickness, and styling options. You got a lot of granular opportunities here to style your braids on the fly. In order to help complex grooms to blend better within a complete hairstyle, we are also adding a tool called the cornrow styling tool. In this example here, a guide groom node is used to sculpt new mirrored curves on the head, and these curves are then fed into both the cornrow and the braid tools, with their output merged together. When a curve is drawn, both tools generate cornrows and braids at the same time, following the same path. The cornrow tool includes options for adjusting the push and the bending of it, with lots of controls. Density and scattering distance can be easily adjusted using simple sliders. So merged into a single workspace, it doesn't take more than sculpting a single curve to quickly build a detailed braid layout that sits naturally on the surface of the head, just drawing one curve. So now onto our modulation tools. This second set of tools we introduce focuses on strands modulation. We want to remove as much graph network complexity as possible, as well as reducing the amount of Vex or Python coding knowledge that is necessary for the most trivial or repetitive grooming tasks. So we are adding plug-and-play modulation nodes for more accessibility. But we're also introducing a new clump node called the MetaHuman Groom multi-clump that allows for multiple variants of clumping within the same system, similarly to the bun and the braid variants that we've seen earlier, as well as the ability to twist. As you can see in the bottom middle, there's like the clump twists on itself. It powers our subclumping method that I will present to you a bit later. Two examples of quality of life additional nodes that we provide are the Scraggle node and the Spread node. The first provides a straightforward way to apply noise modulation to curves by simply leveraging Houdini's native noise, but optimized and bundled up to be used on curves. Users can control the noise along the curves, switch between different noise types, adjust parameters like the frequency, the amplitude, and applied randomness. Very easy to use. The Groom Spread node increases the volume and shape of the curves by simply leveraging Houdini's bend tool without additional setup. Its behavior may be familiar to the Maya Exchange users already, as it allows for spreading curves on two different directions, called a round and lift spread. Again, we wish to simplify as much as possible very redundant grooming actions that could otherwise require additional graph setup or even trivial vex coding, but which can end up being time-consuming and additional efforts for no real good reason. Another good example of our simplification toolkit is the MetaHuman groom width node. It allows quick curve thickness modulation at any point in the graph by simply dropping and connecting the node, again removing the need of point wrangles or vex coding for such an essential and simple action. It allows different modulation modes such as simple gain, overriding, randomization, and it comes with a lot of procedural masking options as well as effortless usage of masks and textures. Controlling curve thickness is essential during grooming, both for look development and optimization. It even becomes critical when we are creating new LODs, for example. What is also critical is the ability to paint masks and textures for grooming. We are adding another set of tools focusing on this topic. In this example here, this modified version of the texture mask paint node provided by SideFX allows users to plug in curves as well as the first input. As you can see, the painted texture is automatically transferred to the curves and can be composited with other existing masks using the Combine tab. This enables quick, on-the-fly remapping of a new curve attribute, preserving the texture resolution accuracy, but allowing curve modulation with it. In this example here, creating a quick tips level mask based on textures using a single node with no additional setup or vex coding. Another node called the attribute UV jitter is designed to quickly add jitter or noise to existing masks. It's a fast solution to add more organic irregularity to painted masks on the fly. In this example, mask A gets applied noisy edges when mask B drives where the jitter is being applied, enabling targeted modulation. This setup is, for example, useful for creating an irregular hairline on the forehead, for example, while maintaining your smoothly painted texture on the nape area. So you can target where the jitter is applied. Now let's jump into a big topic for grooming. It's clumping. As introduced earlier, at the beginning of this session, clumping can make a significant difference between a low-quality groom and a polished one. Our goal here is to remove from users the struggle of building complex clumping graph with a quick and robust solution. As shown here, the master clump has been broken down into several colorful primary clumps. Each primary clump can twist independently and be modulated by adjusting the tightness, the curl, the scraggle, adding flyaways, noises, length breakups. Primary clumps can then be divided into secondary clumps, which also support independent twisting and the application of any modifiers introduced earlier while maintaining the integrity of the primary layer. The same is true for tertiary clumps, an even smaller layer of subclumping made for tiny details and flyaways. This robust pre-built setup enables the entire structure to retain its integrity from guide clumping down to tertiary clumping. And it's all available by using a single node. That node is the Groom Builder. It's our jack-of-all-trades tools for grooming. It uses point attributes and textures for density mask to generate new curves, as you would use hair generating from SideFX. But it can also take in existing curves as a source, like this high-density ponytail here, for example. From there, Groom Builder let users layering in modulation and styling. In this example here, there's already some clumping that is set up down to tertiary clumping, as shown earlier. And we've added flyaway clumps, adjusted all layer tightness, and introduced length variations. It's also possible to add after clumping styling and modulation on strands, adding global flyaways here, a bit of around spread to boost the volume, some frizz to break up the parallel lines, add length variation to break up the tips. Overall, the Groom builder makes it easy to go from a basic, as shown here, to an interpolated groom to a more advanced and stylized result in just a few clicks using a single node in your graph. So we've covered a big portion already, and we will now look at other types of nodes that we're adding on top of the artistic grooming nodes. It's our utility-centric nodes. Our first example here is the groom curl node. So it allows filtering of the input curves using various parameters such as probability, length, and more. It can take an input mask to modulate culling based on its values. So a mask going from 1 to 0, 1 will be preserved, 0 will be culled out, but the values in between will be used as a probability values for smooth transitions. And you can also use it to filter attributes to isolate a unique centroid curve out of a single clump, for example, as you will see very soon. All these filters can be activated all together for combined effects. Yeah, clump attribute. So as you can see here, each color here is a unique clump ID, and you can isolate one centroid curve out of it. So it's very useful for optimizing grooms, but also to create new set of guides that are like literally output from your original groom. We're also introducing the Viewport Light node. It's a convenient solution to add a grooming camera. It's useful for digital grooming and matching a background reference of a human actor, for example. So you can lock the camera and eyeball it around your reference. And thanks to the exposed options, background color and different viewport quality presets are easily accessible in just a click to make sure that your groom looks as best as possible in the conditions you want. It also enables switching between 3 different light rigs with intensity, color, and rotation controls. 2 of these light rigs are locked to the same direction as the camera to ensure that you have consistent lit if you want to do like viewport turntables or things like that to quickly iterate. Also part of the utility nodes is a set of groom validation and debugging solutions, such as the Groom Doctor, that takes all grooming elements, such as strands, skin, and guides, and runs a complete diagnostic on them that helps making sure that the groom is ready to be sent to Unreal Engine and create a clean groom asset. So it will be able to repair automatically if you want some of the errors, but also it can create a grouping based on some things that might be problematic that you might want to fix on your own. So it will also make them obvious for you. It will report them. The Groom Transfer RBF will make sure to transfer both strands and guides from the source to a target MetaHuman head in a robust way. I insist on the fact that it's doing the transfer on both elements, strands and guides, in a consistent way, because both are needed for a good groom asset in Unreal Engine. Making it easy to populate on different MetaHuman heads, for example, or iterate less painfully with new head shapes coming from the modeling team with production updates, for example. Finally, we are adding a dedicated tool called the MetaHuman Groom Export. It takes strands, guides, and skin as an input, and is able to pull all the data from a single groom workspace that was used for grooming, so in a plug-and-play fashion too. So if you've been grooming in a groom workspace, outputting the strands, the skin, and the guides data, you simply need to tell the exporter to pull the data from that single workspace, and it will bring all the correct info by itself. You don't have to pick each element one by one. It provides useful export options like adding color, attribute management, and the ability to bake a quick on-the-fly ambient occlusion on the strands as an ambient occlusion attribute. That is like just made right before export, which is very useful. The result is an Alembic file that is easy and ready to import into Unreal Engine. So now that we've exported an Alembic file using Groom export, it contains all the necessary strand and guide data correctly formatted for Unreal Engine. Once imported, that data becomes a Groom asset ready for shading, LODs, and full MetaHuman integration. You can see the result here. On the left, the Groom inside Houdini, and on the right, the same Groom imported into MetaHuman Creator in Unreal Engine. Let's take a look at how to do that next. As we move into Unreal Engine, this plugin takes the Alembic file and converts it into a Groom asset, which acts as a container for everything related to Groom. So I'm going to take my time here to follow the video so you can see every step one by one. As you can see on the screen, that includes setting up the hair material assignment, adjusting the strands data, interpolation settings, hair card generation, mesh representation, and configuring physics parameters like stiffness, and lastly, level of details. So after importing, the next step is to create a binding asset, which links the groom to a specific skeletal mesh. In this case, the MetaHuman groom head. Once the groom is bound, we make it a MetaHuman compatible by configuring it to a wardrobe item. As you can see, we set the binding, and the pipeline is set to default groom. This integrates it to the MetaHuman system and allowing it to be assigned just like any other hair asset. So now we open the new MetaHuman character creator. And once it loads, we can assign the groom directly in the MetaHuman creator interface by navigating to hair and clothing selection and dragging in the new wardrobe item. So now your hair is part of the hair library. So now that we've walked through the full pipeline, from authoring in Houdini to integration in Unreal Engine, let's take a short moment to talk about optimization. This ponytail is a good example of optimized grooming, reduced density, simplified curve, thicker strands where it counts. For instance, the core of the ponytail can be heavily reduced, while detail is preserved along the edges and the silhouette, where the visual fidelity matters most, right? Tools like MetaHuman Groom Curl, MetaHuman Groom Width, and the resample from SideFX let artists simplify and balance grooms right in Houdini before exporting. Level of details help manage performance by reducing complexity as the camera moves away. Techniques like culling and width thickening help maintaining the groom's silhouette with fewer resources. The hair card generator converts strand-based groom into a textured hair cards for distant LODs and resource-constrained platforms. These cards retain the flow, the volume, and silhouette of the original groom while reducing render overhead. All right, let's talk about the most important info here, where to get the tools. You can download them from the MetaHuman for Houdini listing on Fab. There's also a starter kit that includes both the Houdini project and a UE project with a sample MetaHuman package, groom asset, binding, and wardrobe item. It's a useful reference for working across both environments. Now that you've seen what the MetaHuman Groom tools can do and where to find them, let's take a look at what's coming next. We are working on new tools to support more flexibility for grooming workflows. And one of those is the MetaHuman Character Assembler. It's a system that lets you transfer MetaHuman data from Unreal to Houdini, making it easier to groom directly on custom MetaHuman heads. We're also introducing a new set of parametric grooming tools built to help users generate complete hairstyles quickly and from scratch. These tools rely on pre-generated guide data, letting artists produce clean base grooms in minutes. They're ideal for rapid iterations, especially during early developments. Facial hair on MetaHumans is a key focus moving forward. We're expanding the toolkit with tools to support high-quality facial hair creation, including features for eyebrows and eyelashes. And that wraps up the roadmap. For more hands-on info, visit the MetaHuman documentation on the MetaHuman website, download the tools and the starter kit from Fab, and please also reach out online to me or to the MetaHuman team with any question you might have. The team is looking forward to seeing what you create, and I hope today's session gave you a clear look at what's possible with the MetaHuman Groom tools, and thank you for joining me today.